First order linear differential equations. If first order linear differential equation has the form when we use a form for the definition, we have to match the properties exactly. So here this dy by dx is the first order derivative of the function y with respect to x, and this y is the dependent variable. Now these three functions can only be functions of x. No y can be attached here. No form. Let's see some examples. How about x square dy by dx minus sin xy equals 1 over x minus 1. So we can clearly see that the derivative is first order. No power on the derivative outside. We do not want any power on derivative or on y. This is a function of x strictly, this one and this one. So we can confidently say that this equation is linear. And of course it's first order. Just to add a little bit of more detail, I will write linear in y, okay? Because y is the dependent variable here. Okay. Later we will also discuss linear in other variables, for example linear in x, making x as a dependent variable and y as an independent variable, but that will come later. Okay, how about this one? X cube y prime minus xy equals cosine of y. Is it linear in y? Clearly there is a problem. This thing is a problem. Cosine of y. This part is okay. X cube y prime is a first order derivative without any powers. X is a function of x minus x and then y power 1. That's fine. A function of y and also transcendental function of y which we cannot break. So this one is nonlinear in y. How about this one? X square dy by dx minus log of x y square equals x square cos of x. The rest, everything is fine with the equation. Function of x dy by dx without power, log of x minus log of x is a function of x. Here is the problem. Y square. We do not want any power on y or the derivative in this equation, and we have a power here. That tells us that this is a nonlinear. If the equation is linear of this type, then how do we solve it? So let me write the standard form again, the general form. That is a1x dy by dx a0xy equals g of x, and I'm going to call this 1. Step 1. This step 1 is very, very important and is also the most common mistake students do in solving this equation. Dy by dx plus a naught x over a1xy equals g of x over a1x, and we will rename them as p of xy equals q of x. This is the form which we will use to solve the differential equation. The method which I'm going to mention, this method will not work. It will give you mistakes. It will give you error if you do not divide this a1 here and rename these functions, and then after dividing you call this function as p of x and this function as q of x. It's a very important step in the whole solution. Let us start with an example. Example is from exercise 2.3 of the textbook, and it is question number 4. Question is 3 dy by dx plus 12y equals 4. Clearly it's a linear equation, first order. 3 is a constant, but constant can be treated as a function of x, constant function. Now our first step, as we saw up there, is to divide whatever is attached to dy by dx. So we divide by 3 and we get dy by dx plus 4y equals 4 by 3. And that means our p of x equals 4. We generally do not need q of x. It's just we represent here for the sake of terminology. Right. Our next step says, I have written the steps on this side of the border. Step 2 is calculate integrating factor. How do we calculate integrating factor? The formula to calculate integrating factor is e power integral p of x dx. So we do step 2. if equals e power integral p of x. P of x is 4 and a dx. So that is e power 4x. Now the next step, step 3 says multiply equation 2 with if on both sides. Note that it says equation 2. That is very important to remember. Equation 2, okay? Not equation 1. Not equation 1. Equation 2, the one after division. So we are going to use this equation for our solution from now onwards. Not the original given equation. So remember this step, it's very important. We multiply this on both sides, e raised power 4x dy by dx plus 4 e raised power 4xy equals 4 by 3 e raised power 4x. Step 4, left hand side, this is the left hand side. This side is the left hand side. This is left hand side and this is the right hand side. Left hand side will become equal to d by dx of y times if always. Okay, so the left hand side becomes equal to d by dx of y times if. What was the if? E power 4x. Right. I will explain this step in a minute. How does this step work? So for now, we have d by dx of y times if on the left hand side and 4 by 3 e raised power 4x on the right hand side. This thing, these two terms on the left hand side can become one term with the derivative. Now when we integrate both sides, okay, so here we integrate d by dx of y times e raised power 4x and a dx, and we integrate this side as well. 4 by 3 can be outside and a dx. Derivative and integral will cancel the effect of each other, and we get y times e raised power 4x equals 4 by 3 e raised power 4x divided by 4 plus a constant of integration. If we would like to, we can divide this e raised power 4x on the other side. 1 by 3 e raised power 4x over e raised power 4x c over. Of course, there is an addition between, so it goes under both the terms. And this means our solution is 1 by 3 plus a constant, unknown constant, minus 4x. There is no initial condition given in the question, so our unknown constant will remain unknown for now. That completes our question. Let's look at this step one more time. So after multiplying the equation on both sides with e power 4x, we wrote this step directly. The question is, are they equal? Is this thing left hand side equal to this thing? And how do we know that? Okay, let's write it again. It is e raised power 4x dy by dx plus 4 e raised power 4xy. Okay, and now let us expand what we have written, y times e raised power 4x. What is the formula for this one? The formula says e raised power 4x as it is, derivative of y plus y as it is, and derivative of e power 4x, which is 4 e raised power 4x, and y as it is. It's exactly the same. So we have just reversed the formula. The method told us that at this stage always this will happen. If we have done the previous steps correctly, if we have calculated the if we have divided the 3 first, and we have calculated the integrating factor correctly and multiplied correctly, then this step will always be true. You can write it without even making sure, but of course you must make sure that can be your hint whether you have done the previous steps correctly or not. So this step you can write and then check whether it's correct or not. If it is correct, it means your previous steps are hopefully okay. Right. So let's do one more question. This one is question number 11 in the same exercise. Question is x dy by dx plus 4y equals x cubed minus x. What is our first step? Do you remember the first step? Divide by x. Yes. Dy by dx plus 4 by xy equals x cubed minus x over x. You can write this again just to make your life easier, equals x square minus 1, because here x cubed minus x over x can be written as x cubed over x minus x over x. That becomes x square minus 1. So our p of x is, from here, our p of x is 4 by x. Right, step 2. What was step 2? Integrating factor. E power integral p of x. Okay. So we find IF, integrating factor, e power integral p of x dx, which is e power integral 4 over x dx, and that is equal to 4 log of x. Right, here is a $1 million question. Well, I do not have $1 million to give, but still a $1 million question. Question is, can I cancel e raised power 4 log of x, and I cancel log with e and write 4x. Is it true or false? Give your opinion. It is very false. Not only false, it is seriously false. Please never ever cross like this. That would be alright. If we cannot cancel log and e like this because there is a 4 in between, we have to first get rid of this 4 from here. How do we get rid of this 4? We use property of log again in the reverse order, and we write this. There's a property of log that allows us to write a power m, let's say, and we can write a power a power b, and we can write b log of a. This power can come at the back of the log and multiply. So we use this property, this very property, but like this. So we take this b and take it to the power of a. We take this 4 and take it to the power of x. Now there is nothing between this log and e, and now we can cancel them. Now it's okay to cancel them. So this is actually x power 4. Right, so our IF is x power 4. Next we multiply the equation with x power 4. Which equation? Not the original equation, this equation, after division, the one we get after division. dy by dx, so this is x4 dy by dx plus x4 4 by x y equals x4 x square minus 1. If you would like to, you can do one simplification step, otherwise you can write directly the next step. 4 x cubed y equals x6 minus x4. Now our method tells us that this stage it should become y times if, d by dx of y times if, the left hand side, and the right hand side is the same. Let's just check whether it is correct or not. What is d by dx of y times if? that is x4 as it is, derivative of y, plus y as it is, derivative of x4, which is exactly the same. So we are correct. Okay, now we integrate. I'll put the integration sign right here. I'll just write integrate. That gives y x4, because the derivative and integration cancel each other. And on this side, what is integral of x power 6? 1 by 7 x power 7, 1 by 5 x power 5. I think I'll move it a little bit down over here, and a plus constant. If we want to, we can leave it here, or we can divide this x4 on the other side, and that will become, this will be 3 square c times x power minus 4. Right. So the whole story is in these steps. We must follow the step-by-step procedure to solve the differential equation, and do not forget to divide this thing here first before you start. And you will see these steps many times in these questions, these couple of steps, because we are always doing e power, and this will become log. Do move this constant first, then cancel e and log. This is where maximum students make the mistake. Most common mistake comes from there. Next question, I will only start it, and I would like you to complete it later. It is question number 16, and the question goes like this: y dx equals y e raised power y minus 2x dy. Let's say if the question says solve the differential equation, and it does not tell us which method. Maybe our first attempt will be to try to make dy by dx. So we make dy by dx, dx goes down, and this whole thing comes down here, y e raised power y minus 2x. But clearly we cannot make a linear equation out of it like this, because a over b minus c is not equal to a over b minus a over c. So we cannot split these two terms. And even if we can, if you remember in the definition of linear in y, linear in y does not have any function of y. It has only functions of x. That's why I added this linear in y. You see, cos y is a problem. It makes it non-linear. And now we have in our question e power y. It means this equation is not linear in y at all. How about if we flip the equation and write dx over dy? How will that work out if we have this thing over y? Now we have x as a function of y. So our dependent variable is x, and independent variable is y. Now, can we split? Of course we can split. A minus b over c equals a over c minus b over c. Yes, that's very right. This is not possible, but this is very possible. Right. We can write dx over dy equals y e power y over y minus 2x over y. Okay, and that can be written as dx over dy plus 2 over yx equals e power y. If we had written our general form, I'll just write it here. How would that look like? Dx over dy plus p of yx equals q of y. Just swap all the x with y. Okay. Does this fit the bill? So we have dx by dy here, x here, function of y, function of y. So our p of y is 2 over y. Now we repeat the same procedure, but all the variables swapped. So our if will be in this case, if equals e power integral p of y dy, which is integral 2 by y dy. I would like you to complete this question. It's a very good exercise. Please complete these, do these minimal practice set. And for the complete set of practice problems, please see your course page.